All right, so last time we were taking a look at some historical numeration systems. We talked about the Egyptians, and we had just talked about the ancient Romans. We had written down all their different symbols. This is what we had. And after we talked about some of their symbols, we talked about a couple of features that were unique to their system. One of their features had to do with subtraction. So when we had numbers like 4 and 9, we actually don't write out 4 ones or a 5 and 4 ones for 9. We do a subtractive kind of feature. And we talked about having the numbers that were larger than 1,000, a way of writing those, and we did that by putting bars on top. So if there's a bar on top of something, it means it's multiplied by 1,000. If there are a double bar, 2 bars on top of something, it's multiplied by 1,000,000. And so those of you have written down these things. I'm going to flip the slide, but I'm not going to give you time to write them down. Okay, we did this last time. This is what I just said and just talked about, this idea of the subtractive feature and this idea of the multiplication feature. So you can go online and grab this if you don't already have it. So let me just say for real quick about that multiplicative feature, because it's one that maybe you're not as familiar with. So if there's 1 bar on top of the number 5, we get that times 1,000, so that's why that's 5,000. And then if there's 2 bars on top of something, it's times 1,000,000. So this one ends up being 9,000,000. Okay. So let's do some examples. We're going to go both directions, just like we did with the Egyptians. We're going to actually start with one of their numbers, or numbers of theirs, and we're going to turn them into numbers of ours. And there's several ways to sort of think through this. What I'm going to suggest as we work, so that we don't get confused, is to write down what each of their values are in order. Because then we can talk about whether or not we subtract something or add something to get the next thing. So everybody has written down, or should have written down, what M is. What is the value for M?
1,000.
That is 1,000. What is the value for D? That's 500. What is the value for X? That's 10. And then C? That's 100. So this is the first time in this particular number where a smaller number came in front of a bigger one, right? Do you guys see that? That's important. That's a subtraction that we're going to have to deal with in a minute here. And then the II is 2. So the only time we deal with subtraction in the numeration system is when we have a smaller number in front of a larger one. And the only time that happened right here was the X and the C. So everything else just gets, in essence, added together. So I've got 1,000. We're good with that. I've got the 500. No problem. But then I've got a 10 followed by a 100, which is going to give me what number? That's actually 90, right? And then I have a 5 and a 2 for 7. So if I combine all of those together, what do I get?
1,597.
Right. Does that make sense?
Can you explain the X and the C?
Right. So anytime a smaller value comes before a larger one, it's subtracted from that larger one. So when there's the X, which is worth 10, before the C, which is worth 100, we would take 100 minus the 10 to get the 90.
So we would never have to think it's right before the D, so it could be 490.
The only time this one was the list from last time. The only time that we get this subtractive feature, the only time it ever occurs, is for the numbers 4, 9, 40, 90, 400, and 900. So if you don't see a 4 or a 9 in it, basically, it's not going to have a subtractive feature. Yeah. All right. The second one here has some lines on top of some things, right? So again, let me take a minute with you, and we're going to write out the value of each of the symbols, ignoring any bars. Okay, we'll deal with the bars in a minute. What is an X? 10. What is a C?
100.
A D? Good. An L? Good. An X? 1, and then 5. So you're going to need a 4 at the end. You're right. Okay, now what I need to deal with is I need to deal with each of them inside of or underneath bars separately. So this one right here, where it's got an X with a double bar on the top, it's the only thing that's underneath that double bar, right? So he's a standalone by himself number. So even though he's a 10 in front of 100 or a 10 in front of a 400 or a 10 in front of some bigger thing, that has no bearing on the problem because he's a 10 all by himself with a double bar on top of him. So this 10 right here gets multiplied by what number? What happens when you have a double bar? 1,000,000. So let's write this out. We'll come back to it in a moment. So that's the x with the double bar. The next thing is I have a single bar, and that single bar attaches two other pieces together, right? It attaches the C and the D because they're both under the single bar. Now, when I'm looking at that CD right here, we said that that's 100 and 500. The 100 before the 500. So how much is it really worth?
400.
That's 400. So this 400 is going to be multiplied by 1,000. Okay, so the C and the D there is the number 400, and we said that was multiplied by 1,000, right? Let's think where we were. All right, and then I have an L and an X and an I and a V, and that's 50 and 10 and 1 and 5, and they go in decreasing order, so there's no subtraction going on, right? So we can add those all together if you'd like.
No, the last one.
Oh, you're right. Okay, I got ahead of myself. Let's do the L and the X then. So the L is 50 and the X is 10, so I've got 50 plus 10. Thank you so much. And then I have an I and then an V, which is 1 and then 5, so that's 4. There we go. All right, so we have written down 10 times a million plus 400 times 1,000 plus 50 plus 10 plus 4. What number is that? 10,464. Good. Now, you might notice kind of an interesting thing happen, and this isn't by sort of default, it really is the way that it always will happen, is that anytime you have something times a million, it's going to be in front of, if you do the 3 sets of, commas, if you will, it's going to be in front of this set of commas. So anything times a million is going to be written out here. Anytime you have something with a 1 bar over it, with a times 1,000, it's going to be in here. So there's that 400. Anytime it doesn't really have a bar over it, with few exceptions, it's just written after the comma that's at the very end, and we have something in the hundreds or smaller. Okay. All right, it's a little more interesting to go the other direction. Take a look. We're going to take some of our numbers, and we're going to turn them into theirs. So we have the number 2,861. The 2,000 you can actually get without any bars. How could I get 2,000? 2 M's, right? Because 1,000. So I can do 2 M's just fine without any bars. Okay, so that's my 2,000. How do I get 800? So we're doing one at a time. We're doing one number at a time. How do I get 800? Okay, so I need 500, which is D, and then 300 more, so I've got 3 C's. And we can always write 3 symbols, but never write 4 symbols of a number.
Could you do CCM?
No, you can't do CCM. Okay, so again, the only time they use that subtraction feature is when we're dealing with 9s and 4s. And the only reason they're doing it is to avoid writing out something 4 times. Right, so if I had the number 400, one way in theory to write it out would be to write out 4 C's. Well, they're not interested in writing a symbol out 4 times, so that's when they use their subtraction feature. But if we've got the number that's going to write me a symbol out 3 times, we're fine with that one. Okay? How about the 6? How do I get 60? L, because that's 50,
X.
and X is 10. So there's my 60. And then the 1 at the end? I. Not too bad? Okay. Really, you're going 1 digit at a time and you're writing them down. That's actually a really nice feature about their system, is that we don't have to deal with any of things that we're going to see very shortly. Number 10, I have 7,300,999. Okay, so I mentioned this on the last slide. I'm going to mention it again. Think about this as 3 separate numbers. You got the number before the first comma, the number in between them, and the number afterwards. And we can designate where they are by locating bars above them, right? So the first number is 7. How do I get a 7? VII, right? Because a V is 5, and then 2 1s, so there's 7. How do I make that worth 7 million now? 2 bars on top. Again, do not make me guess where your bars are. I want to see very clearly that you know where they start and where they stop. All right? V and then bar bar, or it's VI and then bar bar. How do I get 300? C gets me the 300, and then why do I have a bar, Mason? Because it's actually in the thousands place, right? It's 300,000. Now I need 999. We're going to take it one piece at a time, okay? How do I get this 9 right here for the 900?
I see.
CM. All right, so let's talk about that because this is the first time we've dealt with any of this changing our number with the symbols. C is worth 100 and M is worth 1,000, right? So if I'm going to do 900, I do 100 minus, or actually 1,000 minus 100, but I put the 100 in front of the 1,000 to get that subtractive feature to be present. So I think what I heard you say, Mason, is you'd like to do IM.
Yeah.
And that would be wonderful, except that in their system they wouldn't do that. The only thing that they'll do with their system is they will deal with one digit less at a time. So kind of like one place value. So if you take a look, I know that you didn't see this slide out written in too much detail. But over here, and some of it's been erased even, I don't even know why. Over here what you see is you see this 4 and you see this 40, and this should have said 400. And you see the 9 and the 90 and the 900. Those are the only numbers that get written in that way. The only subtractive features that ever occur are 400, 900, 40, and 94, 9. And they only occur with that number written in front. So we are really going to take them one number or place at a time. Okay, none of this is working out right for me. Where is the one that I was just on? All right, so the 100 before the 1,000 is going to give me the 900. And then how am I going to get 90 for this 9? X first, right? We aren't to the I yet. This one's X and then C, because what's X worth? 10, and what's C worth? 100. So the way I get 90 is by doing 100 minus 10. So with the 10 in front and then 100 next, so then I have XC. Yes?
All right, so you said we couldn't have the same symbol 4 times, but I guess we can because they come up.
You don't have them 4 times to make up one of their digits. Yeah.
Okay.
Like you can't have 4 C's to make the number 400. But you do see, in fact, there's another question that I think Tyler asked last time that we're about to see happen. But yes, you do see 3 C's here and another C, but because of the grouping, if you will, because of the 1,000 here, that's considered a separate value. Yeah. We have our last digit here, which is the 9. How do I get this 9? IX. So I is worth 1, X is worth 10, so IX would be worth 9. Some good sirens out there. All right, the one thing that I wanted to make mention about this is what Tyler had asked a question about seeing a number written in various locations last times, and you actually see this happening 3 times in this particular piece. So we see the C's, the 3 C's that are written underneath the 1,000 bar. We see this C right here, meaning that I'm going to take something that's smaller and do a subtraction feature. And then we see this C right here written so that it's being subtracted from, don't we? And they're separated, in particular, this first C in pink and the second C that's in yellow are separated by a couple other symbols. And we see the same thing happen again with the X. This X and this X right here, they're separated by some symbols. So you can see repeated symbols in different orders depending on what the problem is that you're working with. Okay? There's a reason for where everything is, but this would be correct. This isn't the last folks in this section that we're going to deal with. We have one more set of symbols that we're going to look at, and these are Chinese symbols. You guys ready? Oh goodness. All right, so the Chinese have more than 10 symbols, but it's not as bad as some numeration systems. So let's take a look at some of their symbols. One of the first kind of features that you need to be aware of is that they write their numbers vertically, which means the highest place values on top, lowest place values on bottom. It's a vertical writing. So in other words, like if we wrote our number 237 the way they would, but with our symbols, it would be a 2 on top and then a 3 and then a 7. Okay, smallest value on bottom, largest value on top. That's an important feature. It's still showing, right? Yeah, okay. And then they also have a positional system that I will show you when we get to writing some of the symbols. Let me just write some of the symbols out first for you. First one, value 1. And the value for 1 is just a straight line. Okay? The value for the number 2 is a small line on top of a larger one. For the number 3, we have what looks almost like the dotted line paper you used to use when you were learning how to write, in print or cursive in 1st or 3rd grade or something. Okay? So the short line is between the 2 longer ones. The number 4 looks something like this. I think it looks like window curtains. It's my description for it. The number 5 looks somewhat like an H, but it's not very good. It has sort of a hat on it and it's sitting on the floor. Or maybe it looks a little bit like a chair to you. I don't know. It looks something like this. The number 6 looks something akin to a little person. Let me try him again. Like a star a little bit. The number 7 looks like a slanted T. Like he's laying down. The number 8 looks like the Greek letter lambda. We have a few more. The number 9 looks like an N. And then they have a few more that make them a little bit different than our system, uniquely because of what we're about to see next. The number 10 looks like a plus sign. We skip to the number 100. The number 100 looks like, to me it looks like, and this is probably before your time, it looks like the TNT box that the Roadrunner and Wile E. Coyote used to blow up on the cartoon. If you have no idea what I'm talking about, you can just ignore that description and think whatever you'd like. And then we have 2 more symbols. We have the number 1000. The 1000 looks like a plus sign with a little hat on the top of it, kind of like a cross with a, I don't know, with a little bar on top, something like that. And then my favorite's got to be the number 0, and I say that tongue-in-cheek because we're going to be doing well if I can get any of it drawn. And if you can repeat it, it should be worth bonus points. It looks something like that. If you grab your book, theirs are going to look a little bit cleaner, but it looks something like that. Yes, Stephanie?
There's like a line through the box in the 100, is that right?
The 100 what? Oh, yes. There's a line through the middle of that. Yes. Yeah, that's a little bit sloppy, but yes, there is. Okay. Their base system it's a positional base system, and I'll show you what I mean by that. Okay, so I don't think I wrote it on another slide. I think that it's positional and it's got grouping in it. Let's say that too. I don't think this is written on another slide. So let's go to the next slide and we'll see what we got. You ready?
No.
No, not quite.
Sorry, I'm the worst drawing.
Do you like that number 0? If I could never draw it, I would be happy with that number being 0. But if I have to draw it, I'm not so happy because I don't draw it so well. Okay.
What's going on? Is that like on the 0?
Just do your best, Tyler.
Is it like a box that's on the 100?
No. It almost kind of looks like there's a P down here.
Oh, okay.
It's not exactly what it looks like when you look at the book, but it's sort of like that. There's a reason that it isn't still used in numeration today.
So,
I am told they do still use it in some of their writing, but not in their computational mathematics. Yeah, but it is still used, like if you'll see it like in literature. You know how even somewhat like in literature now you'll see a Roman numeral used in the middle of something or something like that. It's kind of like used in that way. but not used in actual computational mathematics. Okay, so jot these guys down. These are the ones we're going to do. The last one doesn't get grouped with anything. He's all by himself, like he's in the ones place of our number, so this is 5. And if you take this and you look at this, you should be able to simply add this together. What number is it? 935. Okay, so you're just identifying just like you did with the Romans, except that in some sense it's a little bit easier. We don't have any weird subtraction thing going on. Okay? Maybe less familiar symbols, but we don't have any subtracting going on. All right, how about the second one? What about that that first symbol on problem 12? That's a 4. How about the second symbol? That's 1,000. The third symbol? A 2. And then the fourth symbol? A 100. And do you see where the grouping would be? Just cut in half, right? So they're always going to do the number on top of the base 10 value. Okay, so we would always see the 4 on top of the 1,000. We would never see the 1,000 on top of the 4, for instance. It's always grouped with what's below it as the place value. So this number in the position of top is 4,000. This number is 200, right? So our total number is 4,200. And what I want you to see about this number 4,200 here is that I don't have any zeros beneath it. Do you see that? I didn't have to see, I don't see any of the funny zero symbol here. So you might be asking yourself, okay, well then when would I see it? And I'm about to show you. Okay? So we're going to go the other direction now. All right. Clearly did not get everything erased from some previous semester. All right, here's the first one we're going to do. We're going to take our numbers and put them in their system. Okay? So we want to think about what they mean in terms of the place value they're in. For instance, the 2 here at the beginning is actually 2 times 100 because it's 200, right? We have a 0 in our tens place, and then we have a 2 in the last place. And that's literally what this number is. It's 2 times 100 plus 0 times 10 plus 2. Everybody with me? Okay. How do I write the number? And we'll start at the front, and that will start at the top of their number. How do I write the number 2? Right, it looks something like this, right? A dash and then a line underneath it. And then right underneath that I need the times 100. How do I write the 100 symbol? That's that TNT box. Something like that. So that's 200. Here's where I need my 0 symbol. When the 0 occurs between two numbers, 2, 0, 2, right? There is 0 tens in this. That's when I'm going to have that. If I just had the number 200, I would be done. But because it's 202, I need the 0 symbol. So we're going to try our best. And it's not going to look good, but that's what it looks like. Something like that anyway. This is 0 times 10, so I have a 0, and then I've got the 10. 0 times 10. And I also should mention, because it came up, has come up every time I teach it, if I just had a 10 here, like let's just say that this were the number 1, like it really were 110, you would still have a 1 here and a 10 here, and you would still draw the symbol for the number 1 times the 10. You don't just get to put the 10 in and ignore the fact that it's 1 times 10. Are you guys with me on that? You still have to draw the 1 if there were a 10. Like Matthew, if it said... All right, so the one that I was trying to describe is, let's say we had the number 212. This 1 right here would be the number 1 times 10. So you'd have the 1, which is a single line, and then times the 10 underneath it. You wouldn't just put the symbol for 10. All right, we're not quite done with the symbol we had. We have to do 2 at the end. And how do we do 2 at the end? The dash line, right? Okay, so let's do one more. 7612. How do I get the number 7? What does it look like? It looks like that laying down T, right? But how do I make the 7 7,000? Right, that 1,000 symbol, which actually looked like a plus with a little half-hearted line on top of it. So it looks like this. That's the 7 on top times the 1,000 afterwards. How do I get 600?
Lower.
All right, so the 6 looks like this, and then I need the TNT box to make it into 600, right? So that's the 6 and then times 100. And then I actually have one of these. I guess I probably changed it after I'd had so many questions about it. This is the one I was talking about. You see that 1 there? It's not just 10. It's 1 times 10. So we're going to draw it as a 1 and then times 10. You need both of those symbols in there. All right? And then I need the number 2 at the end, which we've done before.
When were we using the tens?
The which one? Okay, yeah, we used the 10 symbol once already. Yep, Tyler.
It's not just, the one's a long line?
Yes, the one, well, it doesn't have to be longer than the rest, but it's the same length. In essence, it's the same length as the symbol that's beneath the 2.
You go back to the chart.
Like this one and this one are the same length. You want to go back to what?
That chart really,
Yeah, we'll see if it's still there. Yeah, no problem.
Sorry.
Yeah. All right.